Hello again. So today I wanted to finish the frame buffer. I started the frame buffer in a previous video, but I wasn't able to complete it. And then when I watched the video back, I realized I had introduced so many problems and bugs that I kept putting off till later, and they couldn't wait anymore because they were actually preventing me from being able to finish the frame buffer. So I wanted to actually finish the frame buffer today. And if we open up we open up the project and we do a run, this is where we left off last time, where basically we just have a black screen. And this is because the frame buffer on the CHIP8 only holds information on whether or not a pixel is turned on or off. So this is good because we're using calloc to kind of allocate just a bunch of zeros, an empty canvas. So this is exactly what we want. Otherwise, if it's 1, we'll draw pixels. And we've colored the pixels as green, but we can't see any. So let's finish the frame buffer and get this thing working. I have this bad glitch where it opens up 2. Okay. Oh, one problem I noticed, again, while watching my other video back, I noticed that I have init scr twice here. This is unnecessary and not good. So if we rebuild, everything should be fine. That's great. So I'm just going to actually commit that real fast. Removed second call to init scr. Okay. And then I just want to make sure. Cool. Okay, so now that that's out of the way, let's take a look at the draw function. So this draw function is doing a couple things wrong, and it's also missing some vital features. If I look at the spec for the CHIP8, it displays n bytes starting at the memory location at the index register, and it writes them to VX, VY. And then the crucial thing, one of the things I'm forgetting here, well, 2 crucial things. I'm forgetting to set the VF register if a collision occurred, and I'm also not XORing the sprites onto the screen. Right now I'm just putting them in memory. This is actually the wrong location too. And yeah, so if a collision occurred and pixels were erased, then VF is set to 1. Otherwise it remains 0. Additionally, too, something I'm not doing is, it's not listed there, but here it says the frame buffer is written in 2 8-bit chunks by reading memory locations. The frame buffer will feature a wraparound that causes the pixels to be written from y plus 0 on the y-axis all the way down to y plus n modulus 32. So this allows for proper wraparound of the sprites that need to be drawn. That's something I'm missing as well. So we need to implement those in our draw function. So these are good because we're just getting the information from the instruction. So what we need to do is well, it starts by saying that we display n bytes starting at memory location I. So that's saying that we're going to be n is from this nibble here. So the memory, remember, in the frame buffer only knows information about whether or not the pixel is on or off. So each byte has 8 of those pixels, and so we want to be able to get inside of each one of those pixels and say, at this memory location, is this pixel? So then we start by saying, for VXVY, is this pixel on? Yes or no? What about the next pixel? And we're checking it byte by byte. So, or I'm sorry, yeah, we're checking it byte by byte, but we're looking by each bit in the byte. So in the first byte, we'll say, is this first bit a 1 or a 0? If it's 1, then we're going to draw it to the frame buffer. We're going to XOR it onto the frame buffer. So we're going to initialize that to 0 because we're going to be looping through all the nibbles for the height, because it also it's saying that we're going to draw from here. This is the first line, and then when we increment, the next nibble is going to say the next one, because it draws sprites at a time onto the screen. So we'll do 0, n is less than the nibble, and then we'll increment that. So then we need to figure out, we need to get the current bit, which is going to be the current bit. We're going to get it by going into the memory, and then we look at I, right? Because we start memory location I. And then for each byte, then we'll say on the next byte, look at the next one. So because we're reading n amount of bytes, so we start with this byte, then we look at the next byte, then we look at the next byte. So we're going to add that to I. So on the first iteration, we're actually looking in the memory location at the index register, and then index register plus I, and then we're going to keep going. Then once we are going through those, we need to start writing them onto the screen on the width. So int, we can say, because now we want to go, actually that's not the bit, I'm sorry. This is what we're doing now. We're going for the bit now. This is the byte. So now then we want to look at the position on the bit. Bit is 0, while the bit is less than a byte, because there's 8 bits in a byte. And then we'll increment the bit. And now we need to get the value off that. So we need to look at the current byte, and then we want to shift over. So we want to basically get just the very first, the most significant bit, then the second most. So we need to shift. Well, it's going to be 7 for the first. No, I'm sorry, we want the lowest. So we're going to shift this byte. No, it's the most significant. I'm going to look at that again. No, that's, well, it's not just going to be, so 7 is going to get us the least significant bit and put in the most significant. That's going to get us the most significant bit. Well, that's actually not what we want. We want 7 minus the current bit that we're on. Yeah. And so then it's going to be 7 shifted, and then 6, 5, 4, 3, 2 until we get to the most. Okay. And then, yeah, and because we're looking at the current byte, so it's going to AND it, and it's going to give us whether or not that bit is turned on and off. And if it is, then we want to set the byte to, we want to set the value to 1. Otherwise, it's going to be 0. Yeah. Okay. Now we need to do some math for the wraparound stuff. So if we do position x is the value that we've gotten out here in Vx. So we're going to do Vx minus the current bit that we're on, and then we're going to, by the frame width, yeah, by the frame width. And then we're basically going to do something similar for y, where we're going to get I, but with the frame height. And now we want to write that to the buffer. So we'll do CPU frame buffer is x plus y times frame width, and then we're going to XOR that with the value that we got. Okay, so we've XORed it onto the screen here. Cool. But now we need to say if it causes any pixels to be erased, we need to set VF to 1. And okay, otherwise it's 0. So let's start by saying that we'll say that we start with VF being 0. So we'll put a comment here, say set VF to 0 by default. And now what we want to do is we want to say if there was a collision, we'll just say like if collision occurred, then we set the register to 1. But now we need to figure out if a collision occurred or not. Collision is how can we figure out if something collided? Well, if there was a collision, if the value of, we'll take whatever the value was, because it's only if the value was 1 or the value at the buffer was 1 or 0, it's exclusively. And so if there's a collision, then it's going to set it to 0. So what we can do is we can look at what we just wrote, y times frame width, and then and it with the value that's there. Because then we'll know that, well, because we just wrote this value there, and yeah, if it's the same value, then we know a collision occurred. Okay. Let's try building this. Oops. And was my iterator there. And was my iterator there too. Make run. And it just bombed. So we get the current byte, and we want to check the value of that byte at the bit position. I think that's actually a little more clear. We'll call it the bit position. Should buy that license. No errors. Just renaming some things. Oh. Yeah. I keep getting confused. I'm thinking of it backwards, where I'm reading from the least significant bit to the most significant bit, but we want to read from the most significant bit each time. So we're adding it because we want to say, is this bit, yeah, because we're looking at it as like, what is this bit? And then we want to say like, okay, well, in this position right here, and then this position. So let's try build again. Hey, look at that. Sweet, okay. Cool, we got numbers written to the screen. Looks like there's some other problems, but hey, we're actually getting something written. Cool. All right. Awesome. Looks good to me. So we'll do git add. We'll just say fixed draw instruction execution. Cool. Let's take a look at that one more time. Okay. All right. We're actually getting stuff written there. It's a bit flickery though. Let's take a look. Is there like a refresh rate or anything? I guess I can just start taking some stabs at it. Let's see if we cut it down in half. So it's twice as fast here. This program that's a testing program, I actually ripped it, which was supposed to tell, it's just supposed to put a random number on the screen, but there's something wrong with one of my instructions somewhere where it's just putting random numbers on the screen. It's supposed to just be like a random guessing game so that you just run it and it just displays a number that was generated by the random number generator. And actually I did this so I could check to see if my random number generator was working properly. Let's look, let's do some CHIP8 ROMs. What about CHIP8 test ROMs? ROM for testing a CHIP8 emulator. Oh, okay. Okay. I think it's testing like this is the opcodes that start with 3, 4, 5, 7, 9, 8, and all those 8 instructions. Let's download this one. Test opcode CH8. We'll show this in the folder. So we'll copy that. Cool. And then, oops, I did not mean to close that out. All right. What was it called again? LS ROMs. Test opcode. Test opcode. We already just need to do a run. Okay. Looks like 5 is busted. Or my frame buffer still doesn't work properly, and maybe it can't say, because I already closed it. It would only say okay for each of them. I guess we can take a look at 5. That's a good. This is cool because it can let me know where to go next to test the instruction. But wait a minute. If the whole thing doesn't work, then how could it test whether or not something was working properly? Weird. We're actually getting stuff written to the screen though, which is pretty awesome. Oh, you know what I just figured? The delay timer. One tick per 60 hertz. Actually, let's see if we can do CHIP8 Pong. Look for ROM. was kind of around Pong 2. Let's try downloading Pong here. I'm going to save it as CHIP8 here. So let's copy that one. Let's go back to Thunar and ROMs. Let's try running it with Pong. Cool. Yeah, okay, and then nothing's executing, and the ball isn't flying around because we never set up the delay. I was thinking maybe the delay had something to do with the 5 ops. So let's see if we can, the sound and timers decrease at a rate of 1 tick per 60 hertz. I don't have anything like that. But just to at least get the delay timer going, we can do if CPU delay timer is greater than 0, then decrement dt CPU. Hey, there's the ball. Cool. Still some flickering. See, yeah, there you go. So there it did the XOR there. Awesome. Kind of painfully slow though. I want to see if it bounces off the bottom here. I can't tell if it'll collide. Looks like it'll just collide. Hey, look at that. Cool. Okay. So we'll do add increased clock speed, and then we also added delay. How do they put it in this? They say the decrease. And and now we also added the, and then you know what, I kind of like putting it on the make file here. I think it was test opcode. Yeah, I think this is going to be the next thing to work on. Making sure that all these can display. I think that's a good place to go next. So Framebuffer's been implemented. It's a little flickery. Well, we could try on the CPU. It's flickery, but we don't need, especially in like this case, like here, if we do this run, it's good, and then it's every time it goes through the fetch, decode, and execute cycle, it's redrawing the screen, but we don't always need to redraw it. What we could do is we could put a flag on the CPU that says whether or not we should redraw the screen. Because it only draws something to the screen when it encounters that, when it encounters the draw. If it's a draw or clear, then we'll say redraw the screen. Otherwise, it never actually, it only draws to the frame buffer, and the frame buffer will only change when the draw instruction is executed. So let's do that. We'll do, inside of here, we'll do unsigned char draw flag. And then over here, when we initialize it, we'll say CPU draw flag 0. And then we'll try over here. We'll say if it's a clear on the screen, then we also want to do it too. So no, actually, no, this is where we're just decoding it. We'll go to the execute, and then we'll basically say you know what, I kind of like having a, I'm going to do that. I'm going to make a, we'll put it under here, void set draw flag. And then we're here in the CPU. We'll look for decrement. Well, I think I put it like right here. No, I just copied both those. Okay. And then we'll say CPU draw flag is 1. And then we can set draw flag, and then we'll do a clear draw flag. Oops. Draw flag is 0. And then CPUH. Clear draw flag, set draw flag. And then back over here on the CPU under execute, we can do set draw flag and pass the CPU. And then by default, every time we, oh no. Yeah, we only need to clear it then once we are drawing. So we'll do, go back to draw here, and then we'll also do set draw flag on the CPU, and then in CHIP8 should probably, we'll do it like this. Then if CPU draw flag is, well, if it's set, then what we want to do is do the draw buffer, and then clear draw flag CPU. Let's try that. Of course, lots of problems. Clear draw flag, expected that on CHIP8C. Oops, CHIP8. Old style parameter, prototype function. CPUH. There we go. Cool. Still works, and now if we leave it on, we're not getting that flicker because we're only redrawing the buffer every time the flag's set, and then we clear the flag because it doesn't always need to be redrawn. Perfect. Okay. Cool. So let's do that. So what do we have here? So git add makefile. We'll just say changed default testing program. Actually, let's add the actual ROM first. Git add test opcode.ch, and that's actually in the ROMs folder. And then we also added Pong here, so we'll add Pong, and then we'll do added more ROMs for testing. And then what we did was, I should really do that, git reset head makefile. So now, okay, so then we do git add, or we're going to commit this and we'll say added new ROMs. Okay, and now we can do the makefile. Change default testing program in makefile. And then what do we do here on the CHIP8? We added that, and then on the commit, added draw flag. Yeah, added draw flag to CPU, added clearing and setting draw flag functions. And then on the CHIP8, we only draw if the draw flag was set, and then we clear it. So then we'll do, we'll add that, and then only draw the frame buffer if the draw flag and CPU was set. Awesome. Okay, I think that does it. We finally got the frame buffer working, and we kind of fixed some of the flicker, because now we're only drawing if the flag is set on the CPU rather than every time it goes through the fetch, decode, execute cycle. So that should actually clean it up. And really quickly, actually, let's just do this. I just want to test it with the Pong now that we kind of it's a little better. It's not great, but it's a little bit better. But we actually got the frame buffer working now. It's drawing the pixels on and off, and they're being drawn in the correct place, it looks like, and it's working with all these test ROMs, so that's fantastic. I think the next thing to go for is with that test opcode. It was the test opcode program that's running on the CHIP8. What it'll do now is we can use that as kind of a guide to make sure that our opcodes are working properly. So thanks a lot for joining me, and I'll see you guys next time.